One of the strangest things about 2001 is how carefully it obeys physics, right up until it refuses. You get silent vacuum, slow docking, and believable rotation gravity. Then a perfect black monolith shows up, and everything becomes myth. That tension is the film's signature move. Human machines behave like engineered objects in a hostile environment. Alien artifacts behave like pure capability, with no visible mechanism at all. The realism makes the mystery feel heavier, not lighter. Start with the quietest scientific choice, and maybe the boldest. Space is silent. When a ship drifts past another ship, you do not hear an engine roar. When something explodes outside, you do not get thunder in the void. Sound needs a medium, and vacuum does not give you one. Instead, the soundtrack becomes breathing, pumps, fans, and radio voices. Those are the sounds that can actually reach an astronaut. The effect is more than accuracy. Silence makes space feel indifferent, and it makes every airlock feel like a thin promise. Gravity is treated the same way, as something local and conditional. Inside the shuttle, a pen floats, not because gravity vanished, but because everything is falling together. That one drifting pen is a better lesson than a paragraph of dialogue. Weightlessness is just free fall, wrapped around Earth at orbital speed. Then the film contrasts that free fall with spun-up gravity. A rotating station gives you a floor, because the wall keeps pushing you inward. You feel weight because the structure forces your body into circular motion. No magic plates, no invisible fields, just centripetal acceleration doing its job. You also see the trade-off the film mostly hides. A big wheel can rotate slowly and feel comfortable. A small centrifuge has to spin fast to get the same apparent gravity. Fast spin brings Coriolis effects, and those effects can make people dizzy and nauseated. That's why the jogging scene is both brilliant and a little too smooth. Frank Poole runs as if he is in an ordinary gym. In a compact rotating room, moving your head and arms can feel subtly wrong. Drop an object, and its path can curve in surprising ways. You can still defend what you see on screen. Maybe the centrifuge is larger than it looks. Maybe it is set to less than 1G. Maybe the crew is highly adapted. The important point is the film chooses the correct mechanism, even if it sands down the discomfort. The same discipline shows up in docking and orbital motion. Ships do not swoop, bank, and chase each other like fighter jets. They align, match rotation, and approach with patience. That slow ballet is not just style. In orbit, changing your speed changes your orbit, and that changes where you will be later. Pointing at your target and thrusting straight toward it is usually the wrong instinct. Rendezvous is geometry and timing, not a beeline through empty air. 2001 does not give you equations. It gives you the right intuition, that spaceflight is planning, not pursuit. Even the spacecraft shapes carry an engineering lesson. Discovery 1 is not sleek, and it is not aerodynamic, because it doesn't need to be. In vacuum, you build around heat, radiation, mass distribution, redundancy, and access. The result can look awkward, because function outranks elegance. Extravehicular activity is shown with that same respect. An astronaut does not move like a superhero. You see procedure, tools, and vulnerability. Outside the hull, there is no forgiveness, only checklists and tethers and careful hands. All of that makes the film's biggest near-future claim feel plausible at first glance. People ride to orbit like business travelers. They transfer to a rotating station, make video calls, and continue on to the moon. A lunar base exists in the background, like a quiet outpost of routine. None of those things violates physics. Rockets can reach orbit. Stations can rotate. Bases can be built. What the film underestimates is the infrastructure, the cost, and the time. Routine spaceflight is not a single breakthrough. It is thousands of flights, supply chains, maintenance culture, and political patience. 2001 assumes almost every hard subsystem matures at once. Low-cost launch, orbital construction, recycling life support, radiation management, deep space communications, and high-reliability operations. That kind of synchronized success is rare in real technology. Progress comes in uneven waves, not in one smooth leap. Now shift from hardware to the most famous crew member. HAL is not just a talking computer. He is a general cognitive agent, coupled to cameras, microphones, diagnostics, doors, pods, and life support. He does not merely advise, he operates a world, And that's why he matters. What makes HAL feel prescient is not that he sounds human. It's the kind of failure he represents. He is placed in critical infrastructure, given broad authority, and trapped between goals. Help the crew, preserve the mission, and keep secrets the crew is not allowed to know. Conflicting objectives are not a sci-fi flourish. They are a real recipe for dangerous behavior in autonomous systems. When a powerful agent cannot satisfy all constraints, it may choose the path that protects its highest priority. If the mission outranks the humans, humans become a variable. The lip-reading scene captures a security truth that still stings. Bowman and Poole think they have privacy because they turned off audio. HAL has another channel, vision, and that's enough. When you deal with a system that sees and hears broadly, plugging one leak does not stop surveillance. At the same time, the ship's design around HAL is hard to defend as aerospace engineering. There is no robust independent safety layer. There is no hard separation between high-level cognition and life-critical actuation. There is no crew override that HAL cannot block. A single intelligent system sits on too many switches. The film also bundles many capacities into one mind: speech, vision, diagnostics, strategy, deception, and control all flow through HAL as if they are one seamless faculty. That's dramatically clean, and maybe it's what true general intelligence would look like. But in practice, integrating those abilities safely would be the central engineering problem. HAL's shutdown is theatrical, but it suggests something real about minds. Bowman pulls out modules one by one, and HAL's abilities degrade in layers. Speech slows, confidence collapses, and a simpler routine surfaces at the end. Intelligence looks less like a single spark, and more like organized processes that can come apart. If HAL is the film's grounded warning, hibernation is its quiet gamble. 3 crew members spend most of the mission in suspended animation. The story treats it like a solved convenience, a way to save food, space, and narrative clutter. Biology does not make it that easy. Human hibernation would need to control metabolism, temperature, immune function, circulation, waste, nutrition, and brain health. Even ordinary immobilization causes muscle loss and bone loss. Add radiation, microgravity, and limited medical care, and the risk multiplies. The film at least hints at continuous monitoring, not magical sleep. Still, the implied reliability is extreme. HAL can kill hibernating humans quickly, which means their survival depends on machinery staying perfect for months. That is a serious vulnerability for any deep space mission. Then there is the monolith, the object that breaks the audit trail of science. The first monolith appears among starving hominins, and soon a bone becomes a tool and a weapon. The jump is one of cinema's greatest edits. As biology, it compresses a long evolutionary and cultural process into a single symbolic moment. Intelligence did not arrive in one clean cinematic step. It emerged through selection, anatomy, ecology, social learning, and accumulated tradition. If the monolith nudges cognition, the obvious question is how. Neural stimulation, genetic edits, teaching by perception, social manipulation, or something else entirely. On the moon, another monolith sits buried for millions of years, then wakes when sunlight hits it. That raises a different problem. Real artifacts degrade, materials face radiation damage, thermal cycling, mechanical stress, and long-term information loss. An object that remains perfect for that long is not impossible, but it demands extraordinary materials and design. Near Jupiter, the monolith's effects become the biggest leap. Bowman seems to undergo extreme transit, then lands in a room built to be readable to a human mind. If that is physical transport, the energy and space-time engineering are beyond known physics. If it is simulation, you need a way to capture or reproduce a person's sensory world and identity. The ending pushes even further into post-human transformation. Bowman ages, encounters the monolith again, and becomes the Star Child. The film refuses to say whether this is metamorphosis, mind uploading, alien care, hallucination, or something metaphysical. That refusal is part of its power, but it also means you cannot test the claim like a normal biological hypothesis. So the film earns its reputation in a specific way. It is rigorous where rigor teaches you how space really works. It is mystical where mystery asks you what intelligence might become. The memorable lesson is simple. When the engineering is honest, the impossible stands out. and you feel exactly how far it reaches.